What else? This is me. I'm Andre, I'm Dutch. And that is what I do for a living. I make SQL servers go faster. Or I make sure you have another one if the first one breaks, that kind of stuff. So I'm a SQL Server guy. I think 10 years ago, as a SQL Server DBA, you spent 80–90% of your time in Management Studio or Query Analyzer or whatever it was called back in the day. And you use a little bit of scripting here and there. Fast forward to today, 80–90% of my time I spend in PowerShell, even though I'm a SQL guy. I even caught myself doing, if I have little scripts, I put them in source code control, and I have pested tests that check this thing, and I'm liking it. I also ran out of excuses in front of my boss. Right? Is it ready yet? No, still bugs. No, you don't have bugs. All your test stuff. Like, oh shit, he can see. So today, I'm going to talk a bit about trying to do ETL in PowerShell. And along the way, I'll go through why I want to do that, and also if I'm successful or not, because I'm going to compare it to SSIS and see if I can make PowerShell just as fast as SSIS. I'll skip to the very end and tell you no, it's a complete failure. Not even close. But oh well, it's that when that demo will go violently wrong. We'll see. Anything else? Violent, naked? Anything else you want to know about me? Nah. It's not that bad. So I should have put this one on. So why do I want to do ETL in PowerShell? I'll get to that. There's a whole thing about I've done so much ETL with a GUI tool that I hate it, and I see more and more people using things like Python. Right? Python is popping up everywhere. I thought, why not try it with PowerShell and see how that goes? BIML, has anyone in the room heard of BIML? A few people, right? If you use SSIS, you're probably not dragging and dropping that much anymore. You're using a language called BIML, which allows you to make SSIS packages. But that has its drawbacks as well. If you want to just make a lot of SSIS packages, BIML is perfect. And then if you want to stick it in a CI/CD system where you want to automate the creation of the BIML, unfortunately you have to buy a $4,000 license from the company that makes it. For big companies, actually I thought for big companies that wouldn't be an issue, but I work for a big bank in the Netherlands, and requesting something for 100 euros or 4,000 euros is really hard. If I want a new SAN for 2 million, yeah, no problem. That they know how to do. The other thing, nah, it's hard. Also, the bottom two items are actually, I didn't make them myself, they're in the standard template that you get as a speaker, and it is a suggestion not to make too many slides. I like that, so I didn't. Although, I saw a bunch of sessions with only one slide. So, I have more, I'm afraid. We'll see. Oh, that goes up. Okay, perfect. Now, a bit about ETL, as I am a database guy, right? So there's been so many attempts to make something with Python or whatever language, insert language of your choice here, go from A to B really fast, right? Insert a CSV into a database, right? Chrissy has amazing scripts that try to squeeze every bit of performance out of PowerShell and do it in a not very hard-coded way, so you don't have to change the script every time you load something. It just figures out what to do and tries to do it really fast. That's really nice, but we're not there yet, right? Because what you usually have is, for instance, in fact tables in databases, this won't be a data warehouse course, but in fact tables, there's also always dimension tables that you have, for instance, your sales fact table, and it holds the key to the date, or a key to a warehouse, or a key to a salesperson. And what you get from the source system is the sale line item and maybe the name of the warehouse or the salesperson or something. So you have to go to the dimension table before you stick it in the fact table, look up the key, and stick that in your fact table. Because the source system doesn't know what your key is, right? And it shouldn't. You shouldn't use source system keys. But anyway, I should tell this at a data warehousing conference, not here. So how do you do that, right? The old school way, and it's still around it will still be around for a long time, is to use SSIS. That looks like this, right? This is a GUI-based tool, and I've come to the wrong place to say how awesome this GUI-based tool is, or any GUI-based tool, I know. But you drag and drop, you spend some time to click and drag and connect things together and tell them what you want, and when you're done you hit OK, and it does things for you, and you can run it from the command line as well. What if you have 1,600 tables in your data warehouse? You do this 1,600 times if you don't use automation, right? And you go, well, all the tables are a bit different, so it's okay. And if a table changes, I'll just open the package that does that table, because you've split it up in separate packages, if you've done it nicely. And you change it, and you save it, and you're done. No big deal. Unfortunately, the next day, an auditor comes and says, you should audit these things in your data warehouse. And now you have to put it in every package, because you didn't do that correctly. So you're opening up 1,600 packages and changing them. I did that once. Yeah, that started with an Excel sheet, with the names, with the tabs for the team, the people in the team, and then the names of the the SSIS packages that we all needed to change. It took us 3 weeks, everybody went through it, and we're done. Yeah, don't ever do that. Don't. That is just, oh well. Also, packages should look like that. They usually don't. This is what they look like often, right? And now you're having a lot of stuff in the same package, and you can't work on it with a team anymore, because even though these packages in the background are XML files, you do not ever want to stick this into a source control system and merge it. Don't do that, because it will never, ever work again. Right? Remember this, if somebody of your team says, let's put the SSIS packages in source control. No, maybe not, or be careful, right? So, and there's another reason that I would like to investigate why to maybe get away from SSIS or do it in a different way, is the cloud. So this picture is a bit dark because it was blue and there's a dark blue background, but it's just a general picture of Azure Data Warehouse, and Azure Data Factory, and all this stuff that you see in Azure. Now, besides the fact that you don't have, well, you do. I was going to say that you don't have SSIS in Azure. You sort of kind of do. You can take your packages and stick them in Azure Data Factory, and it will run it for you. But it's a bit, the implementation is a bit over the top. The Microsoft people in the room, no, it's okay. It's a bit clunky, and I see everybody that has SSIS packages and needs to run them in the cloud, and it goes to Azure SQL DB. That's just a database. You don't have an agent, you don't have any SSIS, nothing. So how would you run them? I see everybody just fire up a VM and have the packages in there. A small VM just specifically to run your packages. That's what I see a lot. So it's a bit, yeah, doesn't sound right to me. Much more important, should I turn that thing around or is it okay? Let's turn that thing around. I forgot. You're stuck for another hour with me. Don't worry, I'm not going to take that long. Much too late for that. People are hungry. If there's one thing I learned, I organized SQL Saturdays, and I forgot to order enough food one time. And then you ask, after that you ask for feedback. Nothing went right. Hungry people are nasty. Oh, that will never happen to me again. We had one time where a year later, I ordered way more food than I needed, and something went wrong in the afternoon. Nobody said anything about it, because they were well fed. Seriously, that helps. So, where was I? Oh yeah. There's a trend going on in ETL world, right? ETL means extract, transform, load. This is exactly what SSIS does. It grabs something from the source, Could be a source system, a CSV file, doesn't matter, Oracle database, because we're migrating all of those, right? It takes something from the source and it does things on the fly in memory, like the lookup of the dimension values, all these things. It does that while it's transforming the data on the fly. And at the end of the pipeline, all in memory, it shoves the result back into the SQL server. That's what ETL means. But in the cloud, that doesn't happen much anymore. And I see it less and less on premises as well. What happens mostly right now is ELT, basically. So you take something from the source, load it into your destination, and then use the power of that destination to transform things. Because SSIS used to be really powerful because the source and the destination systems maybe had SANs underneath and limited capabilities of doing things on large data sets. It would be unwise to do these things, for instance, in a SQL server, where you morph all your data with big clunky queries that would be taking up all the memory and all your TempDB. That doesn't matter much if you have a big Hadoop cluster or a powerful Azure data warehouse. In an Azure data warehouse, you're working a lot with column store. It's also, have you heard of column store? Column store queries, indexes. They don't like updates. They don't like updates at all. So you don't transform things on the fly and then updates the rows that have changed. No, you bulk insert your table next to it and then you join it with the one that's already there and you create a new one. It's better to update, it's better to write a whole new table of 100 million rows than update like a million of them. Because column stores just don't like updates. Microsoft, actually, there's a weird thing. Slightly off track here. If you ever read this about SQL Server, column store, you think, hey, that's great, but it doesn't perform as well for me. Maybe you're updating rows. Stop doing that. Or at least re-index them afterwards. The way a column store index works, they are not updatable. They are read-only. That's the way the compression mechanism works. There's no way you can update that. It's like a zip file. You cannot stick something in. You need to re-zip the whole thing. It's painful if you update something. Why can you update them? Microsoft even calls it updatable column store. Yeah, that's marketing, right? And it's a trick. They don't write it in the column store. They write it in a different table. And when you query it, they grab both of it and join them together. That's what they do behind the scenes. That makes it slower again, right? Because part is compressed and another part is uncompressed. Okay, somebody stop me if I talk too much about SQL Server because I can go on about column store for a day. Let's not do that. But the cloud changes the ETL. It changes it into ELT. You take something from the source and you load it into the destination, and then you do all the transform. You use the power of these destination machines. Azure Data Warehouse, Hadoop clusters, they are much more powerful, and they can handle it way better than an SSIS package. Gets even worse. You have in packages, let me show you. I've got one here. See if you stop staring at a PowerPoint slide the whole time. Not that one, this one. You can't see, oh, that's, it does that. That would be duplicate. Go, yeah. That's the beauty of PowerPoint. There's this mode that I can see something else than you can. I can see what the next slide is and whatnot. If you switch that off, it will still do something weird with the screen. So as soon as you stop your PowerPoint, the screen will switch off. It's weird. And I know there are things that you can do, but they've never worked for me, or they change every time there's an update. So up here, there's a control flow and a data flow tab. So the control flow does something that tells the package what to do in what order. The data flow is where it morphs the data around through different states. The control flow is all that is left in data warehousing and in Azure environments, also in on-premises a lot. Because you have, for instance, Data Factory now in Azure. That's a control flow thing. It doesn't really morph data. If you're using Azure Data Warehouse, it has something built in called Polybase. That is a multi-threaded, super fast way to grab data from blob storage and from other sources. You're not even loading the data anymore. You're just doing it in a control flow. So you're just orchestrating it, basically. That's all you're doing. So here's the thing. You can do this orchestrating stuff with PowerShell, right? Doesn't matter, any language. That's why I see that coming back a lot in Azure. On premises, I see a lot of data scientists, and Python pops up all over the place. Have you tried Python? I cannot wrap my head around this. It has all the curly braces are gone, right? It's just if it's there, then it's part of the thing that's not there, right? I bet they had a meeting somewhere. What if we do if somebody has two spaces instead of a tab? We do a different kind of loop or something. I don't know. It's it looks really easy. I can read it right away, but it scares me a bit. I bet they say the same about PowerShell. But I like to know where the thing starts and ends. So give me some curly braces there. That's where it stops. Okay, fine. Just personal preference. Now, back to the slide deck thingy. Put that there. This is a piece of BIML. This is another attempt to do not the GUI thing anymore. Automate things. BIML looks really easy, right? It's an XML structure that looks exactly like a package. If you are used to dragging and dropping SSIS packages, you can learn BIML right away because you can actually see what you're doing. Oh, make a new package. Here's a data source. Pump that into a table. Oh, I can see what I'm doing here. You can look at at a BIML script and go, this is what the package does. You can almost see the package. I sometimes build a package once to know what I need to do and then go sit next to it, have the package here, and then create the BIML on the fly. You can have it create the BIML for you, but they used to charge you the 4,000 euros again. So this is free. You can just type away. It's built into Visual Studio. But the reverse engineering costs money. I think it's built in now, but it does some weird structures that nobody normally uses and that are really useful if you have the paid product. They go from free to $4,000, and I think they're a bit lost in their model of how that works. Anyhow, if you find yourself with a lot of SSIS packages, look at BIML. Stop dragging and dropping that stuff. Now, this is where, especially my code, sometimes fails. Not sometimes. Your code should not just do the thing it's supposed to do. Those days are way gone. That was how we used to write code. It should now also be very readable for somebody else who reads it, especially if you shared it. The best way for me to learn PowerShell is to start submitting something to DBA Tools. I've learned a ton of things there. That forced me into paste a test, have my naming convention right, have help. Because if you submit your pull request to DBA Tools, they do automated tests. And one of the first tests is, did he provide some tests? Nope, not good, right? Is there help? No, also not good. So it forced me to do a lot of things. I learned a ton from there. I think I tweeted about a year ago, I just did a pull request. The developers may be laughing about this, but I'm a DBA. The pull request, I was staring at the thing for half an hour. So how does that work? The first ones who did a pull request and thought the first one was a bit scary. Right, see? Like, what is going to happen now? Are they going to yell at me? Yes, I know this. They're very nice. So here's the thing that I tried. I wanted to write some PowerShell, ignore the whole orchestration thing. I just wanted to see if I can make something fast. Chris, you already did something that went really fast reading CSV files. I wanted to put some logic in there, and I want to see if I can make it even faster. Yeah, the answer is no. But I tried. You're all going to learn how not to do it. So I looked at memory mapped files. This sounded interesting to me. Now there's two kinds. Can you read that? Should I blow it up a bit? It's okay in the back? Okay. So there's persistent memory mapped files. So I was looking for something that stays in memory and doesn't go to disk, right? So persistent memory mapped files sounded wrong to me. Right? That sounds like you're both, or you're just misleading me, I don't know. But persistent sounds like disk, right? And the explanation also says that. Now, there's also one that says non-persistent memory map files. Like memory map files that are not associated with a file on disk. So it uses a lot of it uses a lot of times the word file to make sure that I understand that it's not a file, basically. It's a piece of memory. And the cool part is, you talk to it in the same way as you would talk to a file. You can just use a stream reader and a stream writer to talk to it, to memory. And one of the other ideas that I had, am I here? Oh yes, I'm here. Okay, cool. Let's go to the code for a bit, show you the memory. Where's the memory stuff? Here, blow that up. Some more. There we go. Too big, or is it okay? Good. In this room is a bit better than the other rooms, but the screens are small and they're very long. So if you're in the end, no matter how much they zoom it, you can't see anything. So what I'm doing up top there is instead of a normal data file, I open a memory mapped file. And as you can see, if I zoom a bit, over here, I need to give it a name, not a file name, not where it is, but just a name. And I need to tell it what the size is. I could not get away from it. So that I need to look at the original file and tell the size or something. So my original plan was, I'll just make I'll start reading the CSV and make a bunch of memory mapped files, and as soon as one is done, I'll take the name and throw that in the pipe. So some other PowerShell process that comes after it just has the name of the memory mapped files, because you can share them. That's the cool part. Just starts reading that file and processes it, right? And you can maybe hand it on to another process and another one, because you're writing memory. Yeah, you say you love it, but it doesn't really work. Yeah, sorry. I'll get to that. So sounds cool, right? One thing you have to keep in mind, there is a structure here. Let me go back. Where I start, where is it? Yeah, the view stream. This thing here, the second one, where I do a create view stream. You need that, and that needs, your stream readers and stream writers need to connect to this view stream. I got it to work without doing that. I just made a stream reader or a stream writer directly on the file, and I also figured out that makes it cooler for me, because I don't have to estimate the file size at the size anymore that I want for the memory, and all the problems went away until I noticed that all I did was create an actual file named system.io.filestream somewhere on a directory. That failed, and it took me hours to figure that out. This is not really fast, right? And then suddenly I got a message like, hey, we cannot delete the file, see on users Andre system.io. Oh, I see, okay. So make sure you use this create view stream to connect through. But after that, once you've done that, it is nothing more than, let me show you, reading a file. And what am I doing here? Yes, so I'm reading a file from disk and I'm shoving it in memory, basically. Just a CSV file and I'm shoving it into disk. So this should, there you go, 3 seconds. This thing has 1 million rows. It takes about 3 seconds to read and shove it into memory. If I don't shove it into memory, it takes 2 point something close to 3 seconds. So there's it looked good to me. But you can tell by my wording that there's a nasty surprise later, right? So what I'm actually doing here, you see the mem file dispose, that is commented out. So I'm not throwing away the memory. The thing is still there. So in the next part, I'll try reading the memory file and stick it into another memory file. See how fast that goes, right? Because that's the important part. I want to stay away from memory. So let's go here. I'll make 2 memory files. A whole lot of closing and stuff. You see it up there, the read this file and the write this file and the read stream, and I'm basically doing everything twice. Get this memory file, stick it in that memory file. And try to measure that again. And my measurements have been all over the place, so let's see where this one goes. Oops. That was slower, wasn't it? So this is not documented, but I figured out what it does. Are you ready for the disappointing part? Even though it says it won't write to a file, but I keep it in memory, it won't keep it in the actual memory. It uses the page file. Somebody's nodding his head like, you found it out. You knew that. You're like, yeah, I knew that. And it's not documented anywhere. You just find it out when you program the whole thing. Why is it slower? What am I doing? Maybe the memory is not contiguous in my laptop, so let's reboot this thing and shut down all the thingies and try it again. No, still slow. Yeah, do I have slow memory in this Dell thing? Let's try this on a Mac or I don't know. But no, it just uses the disk. It's also a file. It's just a swap file. So that was half my presentation done on something that failed, right? Unfortunately. Now, I tried a few other things. There is it this one? This is actually Chrissy's old code that I stole a little bit. Is it this one? Yeah, that's this one. Basically, if you want to process CSV files really fast, the code is old now these days, right? It's been around forever, but it just reads the structure from the database, creates a data table, then starts reading the CSV, and then just in a loop, it adds rows to the data table, and when it hits 50,000, it's going to bulk insert the 50,000, cleans up the data table, and goes again. And that's pretty fast. I didn't tweak it and tune it. Last year I got it to 3 seconds or something. I didn't tweak and tune all this stuff. But the million lines of code should. Here we go. Should. Come on. Starts up a bit slow, makes a connection. There we go. Ooh, this is slow. Ah, here it goes. So, this is not the best I could do on this stuff. Last year I did something on a database, and I made a table in TempDB, and I started multiple threads and everything. You can get this up to go really fast, but this works. I can tell you this is quite a lot faster than Python because it uses the bulk API that you can use on the data table. And Python, I don't think it has one. You never know, because tomorrow there can be a new library that has one. I found a Python library that is called something like ultra-fast SQL inserts or something. And all it does is do insert queries parallel, like really, a lot of them, really fast. That made no sense to me at all. But it is a bit faster than the slow thing that they're using. Not even close to this, though. Use the bulk insert. PowerShell can do that, it's fine. 54 seconds though, 54, let's go, where are we? Show yourself. No, you don't want to show yourself? Oh, here we go. Always tricky to use Visual Studio in a demo. Almost as tricky as Management Studio, which is not as bad as Management Studio connected to an Azure SQL DB. That is, where are we? Here are we. So this is what the power of SSIS does for you, just in case you're wondering what the difference is. You can say, well, yeah, of course, but PowerShell is an interpreted language. So is this. This is an XML file that gets run by an executable on the fly. This is sort of kind of also interpreted. This is extremely optimized for data though. It uses special buffers where it passes the memory along. This is where I got the idea to do the pipe thing.